All right, let's jump right into it. Today we're tackling something that makes a lot of us a little nervous. Algebra word problems. You know the ones I'm talking about, right? They feel less like math and more like some kind of secret code. Well, guess what? Today we're going to become code breakers. So check this one out. You've got stools, you've got legs, you have different totals. It's just this jumble of information, isn't it? It feels like a riddle that's specifically designed to trip you up. But what if I told you it's not a riddle at all? It's really just a sentence that's waiting to be translated. Exactly. That feeling of just staring at a problem and having no idea where to even start, that is completely normal. The secret here isn't about being a math person. No way. The secret is learning how to be a decoder, learning how to see the simple logic that's hiding inside all those words. And that's exactly what we're going to do. We're going to start treating these problems just like a foreign language. It's all about finding those key words and phrases, the ones that unlock the meaning, and turning them into something that's clear, logical, and best of all, solvable. Okay, let's start with a perfect example. Cynthia is 5 years older than her sister Sylvia. The sum of their ages is 13. How old is each girl? This is a classic. Let's use this as our first case study and really break it down. So, first things first, we need a way to represent the stuff we don't know yet, right? Cynthia's age and Sylvia's age. In math, we call these variables. And please don't let that word scare you. A variable is just a placeholder, kind of like an empty box for the mystery number we're trying to find. So we'll just use C for Cynthia and S for Sylvia. Simple. Now for the fun part. Let's hunt for clues in the English sentences. Phrases like is older than or the sum of. Those are our keys. They tell us exactly what the relationship is between our two mysteries. You can see right here how we can take those English clues and translate them, one for one, into a math equation. We just turned words into a logical puzzle. We've cracked the first part of the code. And here's the really cool thing. Most of these problems, they aren't totally unique, one-of-a-kind puzzles. Nope, they actually follow really familiar patterns. Once you learn to spot what type of problem you're looking at, you basically have a blueprint for how to solve it. And this table, this is basically our blueprint. Think of these like different genres of movies. You know, when you see phrases like older than or sum of ages, you're in an age problem. Or if you see stuff about money like worth X, you know you're dealing with a coin problem. Spotting these key phrases is everything. It immediately tells you what strategy to use and gives you a massive head start. It's so true. The moment you can look at a problem and say, oh, okay, this is just a coin problem, your brain can immediately switch to the right strategy. You start thinking about, the number of coins and the value of the coins. You're not starting from scratch anymore. You're following a plan that works. But, okay, what happens when a problem seems less about a formula and more about, well, just pure logic? This is where we switch gears. You go from being a translator to being a full-on detective. Take a look at this checkers problem. Now, you could try to set up some complicated equations, sure. But what if we just try to think our way through it first? This is a puzzle about relationships and what happens when things change. The math itself is actually pretty simple. It's the reasoning that's the real key. Let's just walk through the logic. So, if moving 5 checkers makes the stacks equal, what does that really mean? It means the tall stack lost 5 and the short stack gained 5. So for them to meet right in the middle, the original difference between them had to be double that amount. It had to be 10. See? No complex algebra needed at all, just pure detective work. So you might be asking, why are we even doing this? Why do math teachers seem to love these problems so much? It's because this skill, this ability to decode complexity, is honestly one of the most valuable things you can ever learn. I mean, let's be honest. You're probably never going to be in a real-life situation where you absolutely have to calculate Sylvia's age. The answer to the problem itself, that's not really the point. This is the point. This is the superpower you're building. You're learning how to take any messy, confusing, real-world situation, identify the important parts, figure out how they're all connected, and then build a logical path to a solution. Seriously, look at these skills. This is not just math homework. This is project management. This is planning your finances. This is figuring out why your code isn't working. This is how you tackle pretty much any complex challenge life is going to throw at you. You're building a mental toolkit for structured thinking. So, the next time you see a word problem, I want you to see something different. Don't see a monster.
See an opportunity. See a code that's just waiting for you to crack it. Because you have the tools now. You know how to be the decoder.
And on that note, I'm going to leave you with one last puzzle to decode for yourself. Think about the relationships here. Translate the English into math. What's the hidden logic? Give it a try. I think you're going to be surprised at how clearly you can see the path to the answer now.